Hi, all of you guys that have been waiting for part 6, thank you for your patience. I've been busy with a lot of other stuff and work, but of course I wanted to finish this series, especially after receiving a lot of comments. Last week I focused on the implementation of part 6. I was very ambitious and I wanted a lot more to be part of it, but eventually I had to leave out some of the features. So yes, I will make even more videos about this topic. In this part I want to focus on tracking actual drop events. I will call this the drop zone. I want to reuse the existing codebase and add two new directives, droppable and dropzone. I will show you how these directives will communicate with each other, how to track the events enter, leave, drop and remove, and make it work on all major browsers. I will also explain the skip self and optional decorators of Angular. Finally, I will discuss some limitations that I want to address in upcoming videos. My workspace only exists of code written in this series, and it is just as I left it behind at the end of part 5. Let's start the app and see what it looks like. In part 1 we created a draggable directive, which is able to drag the actual drag events. In part 2 we have shown a simple positioning strategy with the movable directive. In part 3 I showed how another directive can trap draggable elements inside a containing element. And in part 4, I introduced the so-called draggable helper, which adds an extra element which is visible during the drag operation. And in part 5, I created a sortable list. Let's first clean our app and build the skeleton for our dropzone solution. So let's focus on the application model first. We have this simple div element with a little bit of styling. And with the draggable directive from part 1, I can make it emit drag events. And with the draggable helper structural directive from part 4, I have the helper element. Now let's have another element for the drop zone, and I will add some styling for this element as well. The goal is to make this drop zone capable of tracking the drop events. Let's first see how our application model should look like. Our drag and drop system should not know about the application model, so let's forget the whole draggable thing for a minute and focus on what the app normally would look like. For this video I want to work with lists, but of course you can have any model you want. We will work with a list of available boxes, which contains 5 strings, and I will also have a list for the drop zone. Or let's make it even nicer with 2 drop zones. Now I can render these boxes using an ng-void directive. And as you can see, the boxes are rendered perfectly. Now instead of focusing on drag and drop, let's first implement it with simple click events. This strategy can also be useful in an agile software project where you first want to have a simple working solution. When clicking on an available box, I will call a method to move this box to drop zone 1. And when clicking on a box inside drop zone 1, let's move it back to the original list. And the same for drop zone 2. Okay, so let's implement this move method. First, I want to remove the box from all lists, just to make sure. And then add it to the destination list. Let's implement this remove function as well. In this implementation, I choose the old school splice method to mutate the original list. As you can see, this model works fine for this use case. Now that our application model is finished, let's start with the DROPZONE solution. I remove the click handlers and move back the draggable directive. And the draggable helper element for each box. I know there is some repetition in this code, but this might be improved in a next video. For now, this is okay. I will introduce a DROPZONE directive, and it should work together with the existing draggable directive. As you can see, the draggable directive already serves a simple goal, and that is to emit drag events. And in order to respect the single responsibility principle, I will introduce another directive to integrate it in our droppable solution. So it is all more separate. And I will call it the droppable directive. Now, in order to create the two directives, I navigate to the draggable module directory. And I use the Angular CLI to generate them. And these two new directives are automatically added to my module. But I need to add them to the exports array to make them publicly available in my app. So what I need is some kind of communication between the droppable elements and the drop zone. And to make the communication easy, I will introduce an Angular service to facilitate this. And to make this service globally available, I will add it to the providers list of my module. I can now have it injected in my directives. As you can see, one instance of this service is being constructed in my app. The next challenge is how we can track the drag events from inside the droppable directive. Since we can assume that this directive is on the same element as the draggable directive, I can just use a host listener to listen to the output event emitters. And I can have the event passed as well. Now we need to send this event to the service. Let's have an onDragStart method over there as well. Now in this service we want to expose a public observable stream which will contain all the drag-start events. So any drag-start event that happen on this page. The $sign is just some naming convention so that we know it is an observable. Now to pass this event to the stream, I will make use of a subject. And we can now initialize the stream using this subject. It might be a bit messy to have this much code for a simple reactive stream. We see a strict separation between the writing part and the reading part, or in other words, the subject part and the observable part. However, this is considered a good practice because we are now fully in control of the stream. If we want to have additional logic like validation, or we can just put this in the onDragStart method. Now in the drop zone, we can subscribe to the drag-start events using the service and act upon it. Let's put the console log there to see that in action. I have two drop zones, but of course I just have to activate the directive on the second one as well. Now I want to activate the drop zone on the drag start and make that visible to the user. In order to do that, I add a field activated and add a host binding to it, which binds to a CSS class. Drop zone activated. As you can see, the background becomes slightly brighter when I start dragging. Now let's change the style a bit so that only the border color changes. Let's refactor the code a bit so that the logic is put in a private method to make things more readable. Of course, I want to reset the state when the drag operation ends. Use the same strategy but now subscribe to drag events. Of course, we have to add the observable stream mechanism to the service as well. And emit it in the droppable directive, of course. Now the red border will disappear when I stop dragging. Now that the drop zone is able to detect a drag operation, it needs to know when we drag something in it. So basically, we have to know when we enter the element and when we leave it. To keep things understandable and because I don't want to lose your attention, I first use a very simple approach which works on desktop browsers. I will listen for pointer enter and pointer leave events to detect when the pointer enters and leaves the element. I will remember this state by toggling a new property called entered, which will also bind to a CSS class to make it visible to the user. However, as you can see, it will also show this behavior when we are not dragging. Luckily, we already know when we are dragging because of the activated property we created earlier. So we can just check for this. I use an early return when it is not yet activated to stop the method from continuing. It may seem weird, but it does not work. And that is because we are not technically entering the drop zone with the pointer, because the pointer is inside the draggable helper element. When we remove the helper, it works perfectly. Now to solve this, my first try was to add a pointer event none on the helper element. But that did not do the trick. When we inspect the DOM, we see that the CDK overlay from part 4 still accepts pointer events. We can just override the styling in our global styles.scss. And it is very ugly, but it works. To make it a little bit less ugly, we can add a more specific CSS class on this overlay. As Angular CDK is evolving very quickly, there might be an even better solution for this when you are watching this. For now, I accept this solution because later on in this video we will refactor it and use a different strategy, which works better on Android. Now that the drop zone detects both drag events and entering and leaving it, we can emit a drop event. Using this drop event, the application can update its model. This is quite easy. We just have to check in our onDragEnd method if we are still inside this element using the entered property. So let's demonstrate it with a console log. This works perfect. To emit this event, I will use an event emitter with an output decorator. So we can listen for it from within a template. In order to emit a pointer event, I can just use the one from the DragEnd stream. And since we have our application model already in place, it should be easy now to close the gap. However, how do we know what box was being dropped? Currently, I don't have any data transfer mechanism. Of course, I can build one, but We can perfectly have the application keep track of it now by saving the box in the drag start event. Now using this current box that we saved at the drag start, I can move that box to the drop zone list. And as you can see, dropping the box works perfectly now. I see one small bug. The entered state is not properly reset when the drag operation ends. We have to reset it to false. I also need to add the drag start logic to the other lists as well. You may like the current solution, but there are many ways to improve it. What I don't like is that we need to activate both the draggable and the droppable directive on the same element. One way to solve this is by using inheritance and make the droppable extend the draggable. For now, I will just extend the selector of the draggable directive. This will make our app a little bit cleaner. I also want to address two issues. To demonstrate the first one, I will log the drop event. As you can see, when I drop an element that is already inside the drop zone, I will get a drop event as well. Depending on your code, this might even break your application logic. We also cannot remove elements from the drop zone. In order to resolve these issues, we need to distinguish between drag operations from the outside and drag operations from the inside. In order to do so, I will use some advanced dependency injection tricks. First, I will provide the service again on the dropzone directive. This means that for every dropzone in the application, a new instance of this service will be created. To prove that, I will add a console log in its constructor. As you can see, three instances are constructed. One global instance that was provided in my module, and two local instances that are provided in the drop zones. As you will see, it now only listens for items that are inside the drop zone. That is because the service that is being injected in the drop zone is the one that is provided on it. We can bypass this by using the skip self decorator. This means that it will not use the one here, but start the dependency resolution from the parent injector, which will lead to the global one that we provided in the draggable module. Now we are exclusively listening on the items outside this drop zone. Because of that, let's refactor the name of the service a little bit. Now we can have both the global one and the local one injected by having the service injected both with the skip self decorator and without it. Because we need different logic for the inner drag events, I will subscribe to these events and use different methods for them. The first difference is that we are already entered when we start dragging. Of course, it also needs to be activated. And in the drag end, we have to reset this state, of course. Now, exactly like we detected a drop event, we can now detect a remove event as well. That is when the drag operation ends and we are not entered anymore. I will use an event emitter for this event as well. And in our application, we can move the box back when dragging a box out of the drop zone. How cool this solution might look like, we still have a limitation with this approach. As you can see, we cannot drag elements from one drop zone to another, and that is because a drop zone cannot access the local service that was provided on another drop zone. I do have a trick for this. I'm not sure whether this is the best solution there is, but I would rather stay away from advanced DOM logic and make use of the dependency injection framework of Angular. The trick is to make the globally provided service and locally provided services, provided on the dropzone directive, communicate with each other. I want to propagate all events up to the parent services, so that the global service instance will emit events from any dropzone. To do this, I need to have any parent droppable service injected. This will raise an error because it says we have a cyclic dependency. To solve this, I need to use the skip self decorator again so that it starts looking in the parent injector. Now the error is replaced with another one. It cannot find a provider. I need to mark this dependency as optional using the optional decorator. This means that the property may stay undefined when it can't find any instance, which is the case with the globally provided instance. As you can see, one global service is being constructed without a parent and two with a parent. Now if there is a parent, we can propagate the events to it. Everything now works, but we have to be very careful with the solution. When I remove an element from the drop zone, both the local service and the global service will emit a drag event. In fact, the global service could be better named all droppable service or something like that, or any droppable service. In our current situation, this won't make a difference because the state is already reset in the inner drag end. But to be sure, I can have an additional check to make it more safe for the future. Let's make our solution work on iOS Safari and on Android Chrome. For iOS, I will make use of a simulator. And as you can see, the app does not even load. It says it can't find a variable pointer event. And that is because Apple does not yet support pointer events on Safari. To make this work on Safari, I can use a very good polyfill called pep.js that is being maintained by the jQuery project. Let's install the package and load it in our polyfills.ts. The app now loads, but it cannot really drag yet. And that is because we need to prevent zooming and scrolling behavior and activate the polyfill on this element. To achieve that, we just need to have the attribute touch action set to none on the element. Let's implement that in our draggable directive. It now works perfectly on iOS. Let's focus on Android. I will make use of a simulated Galaxy smartphone with Android Chrome on it. We have a much greater issue here. Although Android Chrome supports pointer events natively, it seems that the pointer enter and pointer leave events are not triggered. I'm not sure why. It seems that when it receives a pointer down on an element, it only sends events from this element until the pointer up, similarly to the touch event API. Sadly, I don't have a nice solution for this. This means that we have to use a different strategy for the enter-leave detection. For now, I will just listen for any drag move event, and for every event I will check whether they are inside or outside the drop zone element. Let's implement the missing parts here. For the drag move observable, I just have to expose it in the service like we did before with drag start and drag end. Now let's implement this missing method isEventInside and just return false. You see it now never enters the drop zone, and when I return true, it immediately enters the drop zone. So this approach should work. Now for the real implementation, I will need to have a reference to the element first. So let's have one injected. And now we need to access the DOM API to get a client rect of this element. Let's do that in the drag start using the getBoundingClientRect method. Now I can just check if the coordinates of the events are within the boundaries of the client rectangle. As you can see, it now works. It also still works on any other device. The only limitation that I can think of is that when the dimensions of the drop zone changes during the drag operation, we may encounter weird behavior. It still lacks a nice data transfer mechanism. Now we have to track the data in our app by ourselves. I have ideas for that, which I will show in the next episode. I also want to combine this solution with the sortable list from part 5, so that I can connect 2 or more sortable lists with drag and drop. If you have any ideas, please let me know in the comments. So that was it for part 6. For more Angular videos, subscribe to my channel. My name is Dirk Luik and thank you for watching.